All right, here we go. All of the graphs that we did in polar form, we could actually do in rectangular, which remember is x and y. It's just it would be a lot harder to do it that way. We could also, any of them that we do rectangular, we could do polar. I'm going to prove to you that these are actually the formulas. And what I did on my notes is I just kind of did it off to the side. That's probably your best place to do this, just so you can kind of see where they're coming from. And we'll stick with just the first quadrant because it's probably easier. You agree that's the x value and the y value? It has been for quite some time, right? And theta has pretty much gone where for quite some time? Right there. That's so helpful. How about it's right by the origin? There we go. That's a really bad theta, but you get the idea. And then we're basically, remember, this was all based on a circle, so you do agree that was the radius? And when we were in the unit circle, what was that radius? Was 1. Is it always going to be 1? No. But for what we're going to look at, it's going to work out just fine. So you notice here they're talking about sine and cosine. So let's try that. Let's just find sine of theta, and let's find cosine of theta. So if you find sine of theta, what would it be? Y over R. And cosine is x over r. So based on what I just wrote in red, do you see how we could possibly get to these two? How could you possibly get to those two? Yeah, multiply r to both sides. If I multiply r on this side, it cancels. Multiply by r, there it is. Y equals r sine of theta. And didn't this really hold true for the unit circle? Because r was 1. So wasn't the y just the sine value? Or sine just the y value, whichever way you want to look at it. Same thing here, multiply by r, multiply by r. Again, x was basically just the cosine value. But the radius isn't always going to be 1, and so that's why we have to be able to convert. That's where the formulas basically came from, going in that direction. So what we're going to try and do with example 1 is we're going to try and take those rectangular coordinates, or find the rectangular coordinates for each one. And so here's your conversions right there. I hope you agree that negative 2 comma 3 pi over 4 is fairly obvious that that's polar. Right? I mean, it could be rectangular, but I think it's fairly obvious. And this right here, negative 2 is r, and 3 pi over 4 is theta. It tells you where to go. So to get our x value, what we're going to do is replace r with what it happens to be in this formula, which is negative 2. And then take cosine of theta. See, all I'm doing is following this formula. Okay, do you want to change it to degrees? That's fine. It doesn't matter to me.
What would be the best option?
Doesn't matter. You're going to probably look at your unit circle either way.
135.
Okay, 135 degrees if you want to do that. What is cosine at 135 degrees? Is cosine negative over there? So right there is basically what we're talking about. Cosine's the x value, and it is negative square root of 2 over 2, and square root of 2 over 2. So that is correct. Negative times negative is, so basically it's 2 square root of 2 all over 2. Do any of those 2's cancel? Which ones? The ones outside the radical. Yeah, you can't really mess with that. So x equals the square root of 2. To find y, you're going to use the other formula. R is, well, it's negative 2. And then sine of, again, we can just change it to 135 if that's what you want. So why don't you go ahead and finish that one off and tell me what you believe the y value is. Yes? Mm-hmm. negative square root of 2. Now some of you are saying, okay, that's great, this is pretty easy math, but what does it mean? Do you agree if we had a polar coordinates for you with all the circles on it, you could graph that point, correct? What I'm saying is if I overlaid an xy axis right over the top of that one, and I graphed the point square root of 2 comma negative square root of 2, if I overlaid it perfectly, those 2 points would be in exactly the same spot. If I took the xy coordinate, put it right over the polar one, those 2 points would be in the same spot. Well, is that believable? So let's put some circles on here. 3 pi over 4 is over here. Do you agree with that? And negative 2 then means I'd be over here somewhere, correct? Do you think that would be possibly square root of 2 and then down square root of 2? Do you think that's very possible? It would be. So they would be in the same spot, is the whole idea. One is rectangular. That's this one right here, square root of 2, negative square root of 2. One's polar, same point. They can flip-flop. Okay. So that's how you change over. So why don't you try that one right now on your own? All right, let's take a look. One of the comments that was made is how do you do it if it's not on the unit circle? You can go ahead and use the calculator, that's fine. For x, it's r cosine theta. Y is r sine theta. I'm hoping those two are very easy for you to remember because y is sine and x is cosine. So x equals 6 times the cosine of negative 50 degrees. So it is fine if you use 3 times, that's fine. But what mode should you be in if you're going to type them in this way? Better be in degrees. If you're in radians right now, it's going to try negative 50 radians. That could be a slight problem, not going to be the same. So you type that into your calculator. It will be an approximate though, but it's still going to be pretty close. 3.9, yep. And then over here, it'd be y equals 6 sine of negative 50 or 310. And y is approximately negative 4.6. Now let's see if that makes sense. If we had a bunch of circles on here, so forth and so on, negative 50 is down here somewhere, correct? And then plus 6 would, I don't know, maybe out in here somewhere, right? Well, that's really horrible, but it'd be much higher. And do you think that, well, it's a little bit lower than that. So 3.9, 4.6 is at least in the same quadrant? Yeah. Okay, and so that's why you are actually getting the exact same point. Okay. Any questions? Okay. Going that way, changing into rectangular is sometimes the easiest, especially if you just get a point. As you can see here, changing the other way is somewhat more difficult. We're going from x and y to r and theta. As you can see, r only has one option. It's the square root of x squared plus y squared. Have we seen, x squared plus y squared before anywhere? Where? Okay, well, kind of in quadratic, but Pythagorean theorem. That's really all that is. Don't you agree with my pictures from earlier? Isn't x squared plus y squared going to equal r squared? In that picture? And what did they do? They just took the square root. It's exactly the formula. So r is very easy. Theta is not. Theta I view as having 3 options. You use option 1 when the x value you have is greater than 0. What's another way of saying that? When something's greater than 0 is when it's positive. So this is for when it's positive. This is saying when x is less than 0. So this is when x is negative. This is said when x is 0. Well, that's when x is 0. And let's face it, when x is 0, do you agree you're either going to graph somewhere up here or down there? And isn't that either positive pi over 2 or negative pi over 2, depending on which one you're on? Obviously, if you're up here, it's positive pi over 2. If you're down here, it's negative pi over 2. Is there anything wrong that if it ends up down here, you say 3 pi over 2? That's fine. They just tried to make this formula easier for you and just gave you the 2 options. It's really your job to figure it out. All right, so we're kind of hoping for option 3, right? Those are kind of the easier ones. So here we go, A. So what quadrant would A be in? If I had to graph it right now, rectangular, it would be where? Second quadrant, all right. So let's take a look right now. Let's find R. It's the square root. I have to take negative 3, which is the x value, and square it, plus the y value squared. Well, that's not too bad. That's pretty straightforward, I think. But be careful. If you get too comfortable with that calculator, negative 3 squared might not quite work out right. It is 9 plus 25? Unfortunately, 34. I wish it was 36. A square root of 34, is that something we know? No, 36 is. So we know square root of 34 is going to be just less than 6, right? And we can go get decimal on that. It's about 5.8. So r is approximately 5.8. So if I was writing it this way, it'd be 5.8 for radius, comma, well, we don't know theta yet. So for theta, should I attempt option 1, 2, or 3?
Option 2.
Look at x. X, not r. X. X is negative, so we will be doing option 2. Yeah, you don't look at r, you look at x. So when it's less than 0, theta is, all right, so theta, I take the arctan. Now what's that again? How do we sometimes write arctan? Yeah, tan to the negative 1 is how we write that. Of y over x, so 5 over negative 3 plus pi. Now if I'm going to add pi, what mode do you suppose I should probably be in for that? Or if you just want to do it differently, you could, instead of adding pi, you could add, if you wanted to change it to degrees, you would add 180 degrees. If you want to switch it over that way, that's completely up to you. But I would, it really doesn't matter which way you guys want to do it. You just have to tell me, and that's how you can do your problems. So which way you want to do it? Okay, so in your formulas then, you might want to kind of look at it that way and say 180. The key then is when you do the arctan portion, you better be in degrees if you're going to add degrees to it. So make sure you're in degrees when you do this portion and add 180. So what do we got? 121? 121, careful. You think that's in the same general location? Because what did you say about the first one? Negative 3 comma 5 was in which quadrant, did you say? Second, does 121 degrees match up with being in the second? Yeah, very believable. Why don't you go ahead and try B right now? I'll go around and help with calculator issues. All right, let's take a look at number 2. Okay, once again, which quadrant do you believe this one will be in if we just graphed it right now, rectangle? First quadrant. So when we get done with our problem, you should look at your polar and say, would that be in the same spot? You know, is it believable? Again, radius is pretty easy. You just take the square root of 2 squared plus 3 squared. You know, nothing too special here. So r is the square root of 13, which isn't very nice. It's not the best, but it comes out to be approximately 3.6. I'll put it right here, comma this. Now, when you're going to find out which option for theta, do you look at the 3.6 or do you look at the 2? Yeah, you got to look at the 2. And so which option are we looking at? Well, we're looking at the first one. And so we have to take, I'll do a different color here. Arctan, I'll write it as tan to the negative 1 this time to help you out, of 3 over 2. Do we add the pi this time or add the 180? No. And if you're in degrees, it's approximately 56.3 degrees. Once again, if you were to graph that point, is it believable? Is it even in the right quadrant? Yeah, it's believable. And our y value is bigger, so that does make it past 45 degrees, so that also makes sense. If the y value was smaller than the x, it'd be less, right? If you're in radians, that's also fine. Be 1 point something if you were in radians. Okay. Any questions? Basically, the reason for number 2 that you add pi is, remember, your calculator only gives you the first place the answer happens, correct? So arctan takes care of basically quadrants 1 and 4, and then if you add 180, it takes care of 2 and 3. And let's face it, if x is less than 0, isn't that going to be in either 2 or 3? Yeah. And so that's why you add pi. You just move it that far on the unit circle is the only reason that happens. So this one, 0 is always nice. But where would that technically be? Well, that'd be right down here, right? Right about there. And so I'm hoping that you really don't have to do a whole lot of work to find that angle, because look at where that point is. Is it okay to say 270 degrees? Yeah. Is it okay to say negative 90 degrees? Sure. Negative pi over 2. Sure. All of those are fine, whichever one you're more comfortable with. I'll just say negative 90. And I'm hoping that you don't have to do a whole lot of work on radius either. Yeah, isn't it just going to be 6? If I put all those circles in there, it has to be 6. But if you want to see it the other way, you would take 0 squared plus a negative 6 squared. R would equal the square root of 36, which just comes right back to 6. Okay. Any questions? Yeah, example 3, there's actually 2 ways you can do it. Do you agree if we made an XY table, we could probably go and graph that one right now? But x squared and y being squared, does anybody remember what that would actually be? X squared plus y squared equals 25. You covered it in geometry? Okay, 0 and 5. 0, negative 5. Negative 5, 0. Those of you that are currently in geometry, what would this graph be? A circle, thank you. X squared plus y squared equaling a number squared is a circle. Those of you in geometry, it's a circle with radius. What'd you say? 5. X squared plus y squared equals r squared. So there's 2 ways you can actually algebraically get to the polar form, because I hope you realize x squared plus y squared is rectangular. One of the ways that you could do it, replace x and replace y. Well, if you look on the very front of your notes, it tells you what x is, doesn't it? And it tells you what y is. You can completely replace it. So x is r cosine of theta. So I'm going to take x, rewrite it as r cosine of theta, but it has to be squared. Plus y is r sine of theta, but it has to be squared. Can I replace the 25? Is there anything on the other side to replace 25 with? Not really. Now, technically, that is in polar, but is that normally the way that we write polar? Normally, it's r equals, correct? Yes, question? Okay. So we got to get r by itself. Well, that could be tricky. Well, if I take this and square it, it would be r squared cosine squared. Let's see if you can tell me what the next one would be then if I square it. Yeah, r squared sine squared, yep. There is actually another way to do this problem. I chose to show you this way because I wanted to see how much you remembered from just being able to do algebra with the trig. We're kind of just simplifying. I would take out more than just an r, but that's a great idea. Let's take out, that's a beautiful idea. Let's factor out r squared because you were told if they do have something in common to factor it out, correct? And then what would be left inside the parentheses? Oh, some people are looking ahead. This is very good. Now, what are these people talking about that they're saying this is 1? Where's 1 coming from in the heads here? Yes. Oh, cosine squared plus sine squared is a Pythagorean identity that equals 1. Agreed? Cosine squared plus sine squared is just 1? Yeah. Okay, so r squared times 1 is r squared equals 25. House 5. So r is technically positive and negative 5. But in polar, does positive and negative, when you're doing the r equals 1, does that really make a difference? No, because if you had all your circles in here, r being 5, 1, 2, 3, 4, 5, what would you make? The whole circle. If you graphed this one on rectangular coordinates, it would be a circle centered at the origin with radius 5. Same exact graph. Now I chose to show you this way because I wanted to see what you would do here, and you did a great job. Anybody see another way, or is there a question? Yes.
Well, I think I have a theory, but I'm not sure if you can do this. If you like square root that square plus y squared square root 25, so that's just linear.
Not quite. Uh,
But maybe like this, and then change it into like,
there we go. That's what I needed from you.
so you just like the square root of x squared plus y squared equals 5.
I see exactly what Jen is talking about, and this is definitely the quicker way of doing this problem. Look on the top of this page. It says r equals the square root of x squared plus y squared, correct? Everybody see that? So here's what Jen is saying. Take the square root of this side and the square root of that side. Can I now replace this side? What can you replace it with? R. That's because she's special. I was wondering if anybody would notice that when you go from one form to the other, there's a lot of ways. Try and find the best way. And if you get stuck, is there anything wrong with saying, okay, what's X? What's Y? And doing it that way? No, that's fine. Okay, some of the conversions are going to be harder than others. You're going to have to think. Any other questions?